Okay, so confidence intervals. One of the things you can kind of apply this to, although it doesn't necessarily fit the requirements, but when you look at, do you guys ever buy anything on Amazon?
Yes,
Do you ever look at the reviews?
sometimes.
So if you see oh, this is nice, it has a 5-star review for whatever you're buying, and then you look and you say, well, there's only one person that reviewed it, right? Does it give you a lot of confidence?
No.
No. But if you look and you say, or like if you're buying something on eBay, the same thing, the seller's rating. If the seller's rating is, they have 2 people that have rated them at 5 stars and they're selling you a used phone, and it's a good deal, there's some red flags. Man, it's a really good deal. And interesting, they only have 2 stars, or 2 ratings, I'm sorry, a 5-star, but only 2 people have rated, there's red flags. But if you go on there and it's a good deal on a phone and they have 60,000 people have reviewed their products, it gives you, and they have a 4.8-star rating, or if you're on Amazon buying something and there's 60,000 reviews of something, it's 4.8 stars, it gives you a lot more confidence, right? In buying that, saying this is probably a legitimate thing, or it possibly does work well. So you can actually apply this. It's a little bit different because this requires it to fit in a little bit of the standard normal curve stuff, but you still can apply this method to looking at how confident are you that the reviews, if you will, are accurate. So again, if there's only 1 review, are you really confident that that's accurate? No. If there's 50,000 reviews, it gives you a lot more confidence that it's accurate. How much confidence is what we're going to look at. There's a range that you can get into. So there is a formula, and we'll talk about the parts of the formula. And what that is the formula is, and I will give you this formula on the test because it's somewhat lengthy. And then we'll talk about what this means here. And then, so yeah, you want me to memorize this formula. And then less than P plus 2. And then we'll talk about the P with the bar over the top all over N. Okay, now this one is a 95% confidence interval. When it looks like that, you can have a 99% confidence interval, and with that, it's actually the exact same formula for a 99% confidence interval. However, the only difference is in the 99% confidence interval, the 2 becomes a 3. That's the only difference. And the number 2, which you may not recall, and the number 3, and the 95% and the 99% correlate to, if you go back to page 663 is where it's at, and the standard normal curve, and what this stated was, if you were 2 standard deviations away on either side, 95% of your data fell within 2 standard deviations. And then 3 standard deviations away, you had 99%. And so the 99%. So the formula ties into that, with the 2 being 2 standard deviations is the idea. And then with its 99%, it's 3 standard deviations. But I will give you this formula and this formula. I'm not going to rewrite the whole thing on the test. All you have to do is plug in numbers basically for that. So this is the standard deviation, and then we'll do an example here. So when we look at this formula, though, the P with the book talks about this. The P is the population proportion having a given characteristic. So this is the population that actually has the given characteristic, or if you will, like the rating, or that actually, you know, if you were doing a poll about do you think that, you know, President Trump is doing a good job, right? They're always asking, like, do you think, you know, the president is doing a good job? P would represent that that's actually the percent or the proportion of people that believe President Trump is doing a good job. Well, the only way to really know that is if you survey every single person, which isn't going to be possible, right? So, but that would be, hey, if we knew that we were able to survey every single person, that's what P would stand for. That is the proportion of that people think Trump is doing a good job. So maybe it's like, okay, 60% of the people believe that. So what you'll see though is in stats, I mean, do you guys read anything or hear anything about like, oh yeah, 60% of the people think that Trump is doing a good job, or think the economy is going well, or maybe 20% of the people are, I mean, if you're reading anything in politics, there's these types of surveys that go out. So they've surveyed people, or this was the most watched television show, or the most watched, you know, these type, you know, Super Bowl. There's different things out there. Did they really survey everybody and say, was this the best television show or movie, or, you know, they didn't survey everybody, but they said, hey, they're making a judgment about this, P, because they couldn't survey everybody, but they made a judgment. So if you read, and it says 60% of the people think Trump is doing a good job, where did they get that? Well, they sent out surveys or made phone calls or stood in front of your grocery store, you know, or had an online survey. They did something and people responded. They obviously were not able to ask every single person, because you weren't asked, I wasn't asked. So they weren't able to ask every single person, but they make a statement of fact, which is based off of some mathematical statistics. You actually don't know what it's based off of, you just read it. Right? But in that, what we can ask is, how confident are we that this is the actual number, 60%? So what they're actually doing is they're stating P with a bar over the top states that's the sample proportion having the given characteristic. So what they're actually stating is the sample proportion that they surveyed, that's the P with the bar over top, that's the sample proportion. Because with the population, right, they can't survey everybody, but they sample 1,000 people, or maybe 100,000 people, or only 10 people. That's what P with the bar over the top means, is they were only able to sample however many people, and that percentage actually said 60% of the people thought Trump is doing a good job, just for that example. That's what the P over the bar with the bar over the top is actually referring to. P with no bar is if you were able to look at the entire population and then make a judgment off that because you were able to survey everybody. So with that being said, we can, so leave that, we can look at an example, and let's see here. If we go to page 678. Okay, we will look at number 2 here. It says find P with the bar over the top, and then and the standard deviation of P. Also give a 95% confidence interval. And then when we do the example, we'll talk about what the confidence interval is referring to. So if we look at number 2, it says 6 out of 10 doctors polled recommended eating apples. Okay? So 6 out of 10. So our goal is to first find, this is number 2, so it says on page 678, okay, 6 out of 10 recommend eating apples. As long as they're not sprayed with pesticides. Don't tell Fred. I can do it. Okay, so 6 out of 10 recommend eating apples. So we want to, the first thing is we want to find P with the bar over the top. So P with the bar over the top is the proportion, right? Like I said, it's the sample proportion. So obviously only 10 doctors were surveyed, right? So that's a small sample. The sample proportion is then just going to be how many think you should eat an apple? 6 out of 10 people think you should eat an apple. So that would be 0.6 think you should eat an apple. But again, that's just a sample proportion. Now, if you were, you'll notice there they don't say find P. There's no way to find P because that would require surveying every doctor and then giving this is what P is. We don't know. So we only can do this because that's all that we can only survey 10 people or 100 people or 1,000 people. We can't survey everybody. So there's no way to find out what P is. That's unknown. But there is a way to get a pulse of how confident are we, and that's what a confidence interval is, how confident are we that 60% is accurate? Okay. Now with only 10 doctors surveyed, is there a lot of confidence in that? Not a lot of confidence, only 10 doctors surveyed. The more people you survey, the more confident you are. So they just say, hey, write a confidence interval, a 95% confidence interval. So we're going to take this right here. And this is our confidence, 95% confidence interval. Okay, but the next thing they state before we do that, it says, and the standard deviation of P. Okay, so the standard deviation of P with the bar over top, standard deviation of P with the bar over the top is equal to, okay, it's just equal to this right here. P bar over top, 1 minus P bar over top, all divided by N. That's what our standard deviation is right there. So we take the P with the bar over the top, and that's going to be 0.6, right? And then times 1 minus 0.6, so 0.4. And then divided by the number of people you surveyed in this case. So, which would be, how many people did we survey? 10. Right? So we take the square root of that. So as you're following along and writing this stuff down and using your calculator.
Tater, are you not taking notes?
No, he just wants to ask questions later and then be mad at me that I won't help him. It's easier that way, isn't it? Approximately, what do we get? 0.155 rounded? Okay, so that's our standard deviation. So then the confidence interval is we take this right here, and we don't know P, I'll hopefully tie it in here. And we're just going to take 0.6 minus 2 times. You can, you can probably use the rounded value is fine. So 0.6 minus 2 times the standard deviation, 0.155, that's the rounded version, is less than P, less than 0.6 plus 2 times the 0.155 rounded. And that's going to give us this. We end up with some value on the left, some value on the right. Okay. 0.29 on the left. Then 0.91. Now think percentages here. So if you wanted to, you could think this is I mean, sometimes it's easier because like we wrote 0.6 here, right? What is that? 60% of the doctors recommend that. So this is, if you think of it like that, you could say 29% is fine, and then 91%. So here's the deal. What this represents is, with 95% confidence, I can state, which seems pretty confident, with 95% confidence, I can state that this survey, that 60% of the doctors say we should eat apples, with 95% confidence, I can state that between 29% and 91% of the doctors would agree that we should eat apples.
That's pretty wide.
Pretty what? Wide range, right? So and why is it such a wide range? Well, the issue is how many doctors were surveyed. Yeah, sample space was tiny. Now, think about this. If we were to change this to a 99% confidence interval, when you go from a 95 to a 99% confidence, are you more confident, right? To go, I'm now 99% confident. If you're going to say, hey, I am 99% confident, what do you think is going to happen to these numbers?
Get bigger.
They're going to get bigger, right? Because if you're that confident that this data is accurate, that 60% of the doctors recommend that, then you're going to say, hey, with 99% confidence, then all you do to change it to 99, change that to a 3, change this to a 3, now we're talking 99% confidence. So what does that give us out of curiosity?
Between 14 and 106%.
Okay, 106. So with 106%. So yeah, with 99% confidence, you're stating that between 14% and 106% of the doctors would recommend apples for that confidence. So
and possible number of doctors with like 100.
right, yeah, that's why this type of I guess it breaks it because if that's accurate, I'm trusting Riley's math.
It's 107, but yeah.
Well, 106. Yeah.
Yeah.
You round it.
Isn't it if you
Well,
roll out?
if you round the 7 and then round the 4.
Now, if you want to, so then as you increase this,
1.069.
so that's, you can do the same thing with, if you think about it, with an Amazon rating, you can just look at the percentage of the people that would recommend the item, like it's always like out of 5 stars, right? So it's a 4.8, let's say. Or we could even go with a 4-star rating. If it's a 4-star rating, what that means is, right, it's 4 out of 5, which means it's at a 80%, right? So it's 80%, but then you would look at, so when you're plugging it in, you could say, hey, 80% of the people think this is a good idea to buy this item. So they say, hey, it has 80% value, but then all you do is you just change N to however many people are in that survey or in that have left a rating. And so you can actually utilize that-ish to kind of look at and say, okay, there was 20,000 people. How confident am I that this is a good rating? And you can just plug in like 20,000 there or 10,000 or 9,000. So if we were to change this number to 100, okay, we could keep the stats, if you will, we could keep this the same. We could keep it as 60 out of 100, so we keep the 60% or, right, 0.6. We keep the proportion, the sample proportion, the same percentage, so that would be, again, this would stay the same, this would stay the same, but what does N change to? N changes to, now we're saying, hey, we did it out of 100. So let's go ahead and do it out of 100. What is the standard deviation of P with the bar over top, except we did it out of 100? So 0.6, 0.4 divided by 100 now. So the standard deviation should end up being smaller. 0.05, like that?
Yeah.
Okay, so then let's do it for the confidence 95% confidence interval, so let's do it with 2. We're just changing this number now to 0.05, and we should see, since the sample size went up, we should see a narrowing of that for the 95%.
5.2.
So for the 95%, what do we get on the left-hand side?
Oh, wait, I did get
50? Okay. So 50%. And then 70%, right? So let's change that to 70%. So what that states is, and that narrows that substantially, right? So I'm 95% confident that between 50 and 70% of the doctors would recommend eating an apple.
That's much more reasonable.
So that now, and again, if you change that to 99%, that's gonna widen a little bit, right? Because you're becoming more and more confident. The only way you can be 100% confident is
You know every doctor.
if you knew every doctor in the world, right? So, but this is a way to look at surveys. Now, if you get into the weeds of the data and the surveys, if there's something you're really concerned about or interested in, you could probably, if they said, hey, 60% of America believes Trump's doing a good job, you could probably try to figure out where they did how they did the data, what the stats were, and also what the confidence rating was. So if they, and they may say, we have a 95% confidence rating on this. Well, does that give you a lot of it shouldn't give you a lot of confidence, even though 95% sounds good, but what you'd be looking for is like a 99% confidence rating. And then also you're really looking for what was the sample size. That's the big thing. Yeah, right.
So then, depending on what they're looking for, would they take the average of the two numbers, or would they try to put it towards the higher end or lower end, depending on what they want?
Probably you could skew it, put it towards the higher end. So they, something like this, they could say, or 95%, confident, they might skew it. So you'd have to research it, and figure out what they used. Or they may just do, okay, we're 6 out of 10, we have 60%, we're calling it good, and we're not doing, we don't know, we're not telling you.
I'm not telling our company.
Yeah, we're not doing any confidence interval on it, no confidence rating.
We have no confidence.
Yeah. Yeah, in this case, I would have no confidence that that's really true. I mean, you could do your own thought and research that, okay, eating apples is generally probably a good idea.
Yeah.
Maybe.
No, that's it. Can I use version?
Yeah.
If you look at the data, it's only 14% of apples, right?
So, you see commercials, and it's like, hey, this dentist recommends this.
9 out of 10.
Yeah, 9 out of 10 dentists recommend, Crest whitening strips or something. I don't know.
9 out of 10 paid sponsored doctors.
Yeah, right. And you read those reviews or whatever, and some are paid, to give the a positive rating. So it's hard to know. Very hard to know. That's the general idea. I think we're okay from there. Yeah.
It'd be cool.
So, did you guys get your test, by the way?
Yes.
Okay. And Nick was gone Friday, and looked at it because I think I still had his bundle.
You should do how many high school teachers recommend going to college. That would be interesting.
Well, I would recommend it for the right person.
You would?
Well, yeah.